Here, Supply Network Dynamics, Chapter 2, Part 2, Stocks and Flow Modeling. In this entire course we model the world according to the system dynamics view of the world. In the system dynamics view of the world you see the entire world as consisting of stocks, flows and feedback effects between those stocks and flows. What is a stock and a flow? Well, the easiest way to explain this is in the analogy of a bathtub. So here we have a bathtub and we have an inflow and an outflow. And this is the more symbolic representation of the bathtub. So the water level in the bathtub is a rectangle. We call that a stock or a level. The inflow of new water flowing in is this circle. And the outflow, the sink, is, well, another circle. You know the stocks and flows from various fields, although typically they do not use these precise terminologies. In mathematics, we talk about integrals. The integral of something is a stock. And derivatives, that's the rate of change. In chemistry, you talk about reactants and reactant products. So what happens after you've had a certain chemical reaction, and the reaction rate, the speed by which this reaction takes place, is a rate of change, is a certain amount per time unit. Manufacturing, you have buffers, inventory, and you have units per time unit, which is a throughput. Buffers is the unit. Economics, accounting, for instance, a balance sheet is a stock. An income statement is a rate of change, so that's a flow. So the notion of stocks and flows is pretty fundamental to many of the fields and disciplines that our world runs in. System dynamics therefore can also be used in all these different areas to represent concepts from these fields. A little bit on notation. So we have a stock or a level, the rectangle. The circles with the double arrows are the rates of the flows. We use rates or flow, the interchangeable as terms. And when we're not particularly interested in what's happening, we use this kind of cloud system for the source or the system boundary, and you could call it a sink if there's really an outflow flowing into it. And in theory this should be enough, but in all practical models there are also auxiliaries. In theory you could put everything in those rates, but in practice you want to split up long decision equations with the aid of auxiliary variables. And here's a net inflow, for instance, is the inflow minus the outflow. And these variables are linked to the rates by information link. So there's not really water flowing from left or right, but information about how much water is flowing, that is transported from the other side. So that's an information link. The water isn't depleted through this information link, but the information about what's happening is transmitted. The last type of auxiliary is you see this little tilde signal in water temperature. That means that there's a graphical relationship underneath a graph with an x and a y axis, rather than a mathematical formula. There are different ways of looking at, of thinking about stocks and flows, and the best thing is that you can switch between those. So there is this hydraulic metaphor, there is the stocks and flow diagram, there's also the mathematical notion, the integral equation, and you can also think about it in terms of a differential equation. If models become just a little big, then the notion of the integrals and differential equations, where you can have solutions, is futile and more beyond 2 or 3 stocks. It's well beyond 2 already. It's usually pretty hopeless to find a closed form solution, as they say in mathematics. And then we have to rely on simulation to see what the model is actually doing. Stocks are what describes the state of the system. They provide the information about stock, provides inputs for decisions, for actions. But because accumulation over time, they also provide system with inertia. So the perception of me as a teacher is something that is not created instantaneously. There is some memory of my teaching before in your minds, and there's some change as a result of my current teaching. So there's memory through stocks. And because they have memory and inertia, they also create delays. And because of those delays, it's almost always so that systems are not in equilibrium. There are disequilibrium dynamics, contrary to the economic model where you start off with, let's assume that there is an economy in equilibrium. Because always demand and supply are playing hide and seek in the reality, but also in most system dynamics models. A very old and good example of stocks and flow thinking is Joseph and the Pharaoh. For those of you who forgot that story and never heard about it. So Pharaoh had nightmares, couldn't sleep, had a bad dream. The dream was that 7 fat cows came out of the Nile, which he ruled. And after that 7 skinny cows came out of that same Nile. And those skinny cows ate the fat ones. And he couldn't understand what was happening. Joseph could. And Joseph explained this, that these are the 7 good harvests that are followed by 7 bad harvests. And so you should be aware of that. After good times, some bad times are coming. And Pharaoh put Joseph in charge of making sure that there would be no problems. So what did Joseph do? He built big warehouses where the excess harvest from the good years could be stored, from which the people could be fed during the bad years. And that's an excellent example of stocks and flow thinking. In fact, a very good example that should have been followed by many national governments or firms. So accumulate a little bit of your wealth in good times so that you can survive the bad times. Here are a couple examples of stocks and flows. So easy ones are things like population or employees. There the snapshot test works good. So if I look down on a certain scene where people are walking in and out, and I can take a picture and I can count the people there. So that's a level. What I cannot do is calculate how fast they are walking down the street or something. That's the rate of change. There I would have to make a movie. But the snapshot test, if I take a picture of the system, what do I see then? That is also something that you can see. It's more tricky if you have stuff that have to do with memory. Like product price, the price of a kilo of bananas isn't immediately fluctuating from one level to another. You first have to take into account that people expect a certain price, and you can make some rate of changes over that. Because and those expectations are also again stocks, because those again accumulate over time. So it's a particular kind of stock, and triggered by an information delay. But we'll talk about that later on in this chapter. Now we move to the dynamics of stocks and flows.